Hello everyone, today I'm going to talk about our paper, Learning to Estimate the 3D States of Deformable Linear Objects from Single-Frame Occluded Point Clouds. We define our task as a 3D occlusion robust DL state estimation from a single-frame point cloud. Note that here we represent the DL state as a chain of uniformly distributed nodes. Our proposed approach contains two branches to focus on the global and local information respectively. Then, a fusion module is designed to leverage the advantages of both two branches. First, for the end-to-end regression branch, we exploit a PointNet++ as the encoder and regress the node sequence directly. It is found that this branch can output a smooth global DL shape, but usually not accurate enough. To make up for the shortcomings, we decompose the high-level regression task into the local point-wise prediction, which can produce precise but not occlusion-robust state estimations. To leverage the advantages of both two branches, we further introduce a non-rigid registration-based fusion module. By transforming the regression results, we can finally obtain the precise and robust estimations. To visualize the examples are as shown. We can find that our fusion methods can accurately and robustly estimate the DL states in both unoccluded and occluded cases. We choose 3 DLs to test our method in real-world applications. Even in some cases with self-intersections or occlusions by obstacles, our state estimations are still very smooth and precise. We also integrate our methods into a DL shape control task as a perception module. In the presence of occlusions at the initial and middle stage, our method can steadily output precise DL states. With self-intersections while reaching some very complex desired shapes, our method is also robust. In conclusion, we believe our method can provide a new learning-based effective approach for DL perception. Thank you.